recording. Oh yeah, I forgot to get the full version of Zoom, so in the middle we will have to reconnect again. Okay, share screen. Well, today we will speak about robot operating system. Let me remind you the full scheme of autonomous driving. I mean, in the beginning, there is the module that is called perception, where we receive images from cameras, scans from laser rangefinders, and so on. Then, not perception over here, perception. The first model is just image, how to say it, processing. The first step where we just capture the images. Here we do something with these images, where we detect moving obstacles, moving vehicles, and so on. We just try to understand what's happening on the images we get on the first step. Step also number 2, but that is performed simultaneously with this step, with perception, is called localization. Where, according also to images, we try to estimate the position of the moving vehicle. Then there is happening the fusion, and then path planning and action. So today we're talking about something that happens through all the scheme, that can appear over here, over here. So generally, most likely, the biggest influence we will see for this step. We will talk about the framework that is used for robots. This is called robot operating system. So, in general, this framework might be used like everywhere where you can use the robots. Most interesting for us, of course, is autonomous driving, but for this lecture and the next and maybe one after the next, we will just look at the ROS like separately. It just will be some things about the work with robots. So let's start with a little bit with the history. How did the programmers of robots work like 50 or something like that years ago? The robot existed 50 years ago, maybe even 70 years ago, some kind of robot. The common idea was that the engineer, there was not real a programmer, the engineer had to write the software, had to create the software for his particular robot. There was no common interface, there was not even the common language of programming. For example, the assembler language didn't exist in that way that it exists now. So most probably for every motherboard, for every computation device, there was its own firmware and its own software. That's why it was complicated to apply the existing code for different robots. And moreover, it was completely terrible to debug this code. Because if you create your software for your own robot, you also should create your own debugging tool. Yep, your own visualization tool, your own, I don't know, simulation tool, and so on and so on. This brings you a lot of difficulties. And to be honest, this approach exists maybe even nowadays. Most likely, if you want to have your code working as fast as possible on your hardware, most likely you would like to create your own software for your particular hardware. That is called embedded programming, where you don't want to rely on existing frameworks, where you know, for example, exact path of current in your board, and you want to increase the speed of signal. Yep, in these cases, you will most likely you will use your own software. That's why, for example, in NASA, they use only their code for their particular computation devices. Most likely, I don't know, for example, Boost framework for C++ most likely is not used over there. Most likely they implement their own frameworks, their own libraries. But there are several attempts nowadays that allow to reuse at least the code, that provides the common libraries that might be reused. They provide several simulation and visualization tools. So in general, we will learn a little bit about ROS, and this framework most likely isn't used really in the industry. But if you understand everything about ROS, how does it work, how it is structured, it will be easier for you to deal with any other framework for robotics. So if somewhere in your life, for some reason, maybe on your work, you will face some robotics framework, if you have enough knowledge for ROS, most likely you will understand how does it work for any another framework. That was the idea of this framework when it was developed, to provide the materials for learning the, how to say it, real stuff. But still, talking about exactly ROS, it is used for research works. Most likely, if you would read some papers, scientific papers, I mean, about simultaneous localization and mapping algorithms, structure from motion algorithms, maybe even some kind of autonomous driving algorithms. In 50% of these papers, researchers use ROS. Other 50% are for particular industries that use their own software and hardware. So ROS. First of all, let me show you the website for ROS. It is called wiki.ros.org. It is in several languages, and there you will find but you will find a lot of useful materials. You will see the tutorials, the support, the instruction for installation, and so on. Let's see what you can see for installation. There are 3 available, as I said in the previous lecture. There are 3 versions that was released like 4 years ago, 2 years ago, and the US. And I would recommend you to install this one. For the following 3 lectures, you can use any of them. But for the future work that will be held in the end of the course, the only one that is suitable is ROS Melodic and Ubuntu 18. So here you will see all the instructions. You just choose the version of your operation system with whatever you like. I prefer to use whether pure Ubuntu or Ubuntu for Windows that I showed previously. On my particular machine on Windows 10, there is the core for Ubuntu. Let's see. Do we need the graphic interface? Does it need yes, it does. It needs. So you will also need the X server if you use Windows 10. So yes. And moreover, for this particular version, that is not required, that is suggested in the by official Windows support. Pay attention that you disable native Opengl option. Because the ROS visual tools use their own Opengl analogs. That's why you should disable this thing if you would use the Windows 10. It's just a server that is launched somewhere, and that allows you to use graph interface. Well, okay. Now I will show you during this lecture, I will show you some examples of ROS. For the next lecture, I expect that you will install ROS, and maybe during the lecture you will try some things simultaneously with me. Today I will just show you some very simple steps that you will see further on the YouTube. I will upload this video. Oh yeah, about YouTube. I will provide you the link where I already upload the first lecture. I just I share this link with only one of you, but I will write the common letter for everybody. And how to say it? Except of YouTube, there is the Moodle of our university. I don't know if you see it. vac.etu.ru is the, well, it's in Russian. How I switch it in English? There, you have to log in over there. I hope you have your logins and passwords. If you don't, please ask in the masters of the whole program. They should know. And in my courses, you will see the intellectual systems. Here you can see I've already uploaded the first slides for the introductions, and I will upload the lectures, the slides there. You will be able to see the materials. Maybe I would also provide here the links to the link to the YouTube. I am not sure if Moodle allows to do it easily or not. If not, well, then YouTube will exist separately. Okay. Okay, all right. Let's go further. Okay, about ROS. Yeah, this lecture is pretty long, 50 slides, but I think these 50 slides we will carry for the next 3 lectures. So today, maybe we'll write some code, maybe not. We'll see about how much time we'll have. Okay, about ROS. Despite it is called operating system, it is the framework. It's just the very large framework. It cannot live without a real operating system. It is not real time. I mean, there is the very how to say it, very strong definition of real-time operating systems that should it is, I don't remember, it is very very accurate, but the idea is that it this operating system, the real-time operating system, should answer not longer than in several milliseconds for every request. If it doesn't answer, if it doesn't have enough resources, then I don't know, it's unexpected behavior. It could crash, it could wait, or don't know. Well, the idea of such operating systems is that it also always should answer not simultaneously, but instantly. So the ROS operating system doesn't work in this way, but I will I will often use the word real time. By real time, I would mean, like in the previous lecture, faster than 30 times per second. If we will be able to perform, if we will be able to process some messages, doesn't matter which exactly, some messages faster than 30 times per second, then we will say that we work in real time. Okay, it's just our little definition. And in these terms, ROS might be used as the version, as the framework for real-time tasks, because it on different machines provide, of course, different time, but for some kind of low-cost devices, it still can process a lot of messages in real time. I mean by these words that it is written okay. I mean, it's there are not a lot of problem parts in this library. Of course, it isn't very well documented. So if you would like to see the documentation for something very deep inside, most likely you won't find it. But the most popular things are documented well and are written well. The most useful part of this system is that is open source. Everybody can download it. Everybody can upload some packages for the system. That's why it can be. That's why it grows. Unfortunately, it is a little bit complex. So today, most likely, you will find yourself somewhere in the middle of a lot of brainstorm. So firstly, because you will learn a lot of new things, and secondly, because you will have to learn how do these things connect to each other, are connected. So just have enough attention and patience. Okay, let's go further. A little bit about robots. All the robots, just there are some names that you will be most likely you will face them if you Google ROS by yourself. One more thing, the ROS operation system was developed by the company that is called Willow Garage. Willow. Maybe you will find these words when you Google ROS. These guys created Peer-to bot that has two cameras. I'm not sure which are them. Maybe they are stereo, maybe not. I'm not sure. And the manipulators and wheels. This is the bot that can do, and moreover, there is the laser rangefinder. This bot can do like almost all the tasks that are placed for the robots. But if you want just move and observe the environment, TotalBot will be enough. TotalBot is one of the easiest bots. I mean easiest. I mean that by default it has only wheels and nothing more. It doesn't even have any CPU. You have to connect your laptop for this bot. And also you can connect cameras, rangefinders, and so on and so on. So if you want to create your own bot, if you don't know where to start, and if you want to construct your own bot, maybe you would start with TotalBot. Of course, there are much more bots. If you just Google somewhere which robots supports ROS, you will see the list of like 50 different bots, and there are only registered bots. In general, if you are the engineer of the robot and you want to provide to the consumers your bot, most likely you will provide the support of ROS. We have 10 minutes before connecting. I mean that if you want your bot to be widespread, you will have to how to say it, add the support of ROS. Okay, that was the introduction and where is it used. For us, ROS is useful because there are tutorials for introduction for this particular framework. First thing, and the second thing that it is very well structured. I mean, as I said previously, if you understand how does the ROS work, you will understand how do the similar frameworks work. Okay, this is the system that always should work with some kind of master. You will not be able to launch anything in ROS if you won't launch somewhere. Doesn't matter that on this particular computer or somewhere, you have to run the master. So I open the terminal and type ROS core. The question, ROS core. Do you see that I type in the terminal, or I should increase the font? Well, one yes. What about the other? Okay. See well, right. Okay. If there will be some troubles, please don't hesitate to ask me to increase the font. Okay, I type ROS core and something is launched. Let's look at this log. Well, it said the IP address, Wild West is the name of my computer. You can see, maybe if you put here like localhost, it will still okay. You will see that it says that it launched some kind of server on this IP address with this port. Here you can see the IP like external for other nodes in the network. If for some reasons you will have your system distributed for the network, it is possible. You have to connect to the master node using this IP address and this port. This is like standard port for ROS. It also says the version and name of the distro. And only other thing that it says that it starts the ROS out process, whatever it means. Okay, so if we will open another terminal and also try to run ROS core once again for some reason, it will say that it is already running. So there are two things that you should learn by now. First of all, ROS core is a nice command, and second one, errors in ROS are written in red. So if you would do something bad in ROS, you will see that in red lines. Okay, let's go further. For everything in ROS, you will need a new terminal. So after 40 minutes, maybe I will have like 8 or 10 open terminals. Unfortunately, that is how it does work. Okay, let's go further. The structure of ROS is based on the abstractions of nodes and topics. Every piece of code is launched that is launched on ROS is called node. So you have when you write your own code, most likely you would divide it on different parts that could be launched independently, and every such part is called node. These parts are not connected to other parts directly. They are connected through the topics, and this part, these nodes, communicate through messages. The idea is of message in topics is that we don't know who receives these messages. We just send some messages to some topics. If we are publishers, if we are subscribers, then we just wait in these topics, with particular names, something that we expect. We expect, for example, numbers, like how to say it. That doesn't matter. Some numbers, and we expect that in this topic with this name, the stream of bytes should be understood as numbers. We will see further how does it work on the real system. This is the high-level scheme. Yes, like when you have your system that has several nodes, they connect one to each other through topics. You will never see the the strong error from directly from one node to another. There always be some topics. And once again, about topics, we don't care who would receive our message if we're a publisher. If we're a subscriber, we don't know who sent the message and when will it happen. We just wait for something. That's why here comes the parallel programming. Yes, multi-thread. ROS hides the thread pools, the process pools from you. So you think that you create the order, like usual. You will create some kind of code that without your without your how to say it, approval would be launched in several processes, several threads. You just have to know where these threads appear. Or I will say about it further. Okay, so for now, the nodes and topics. Generally, you can think about the topic as a queue. Yes, several nodes could send messages to one topic. Let's think that our system, somebody arranged one topic. We will know further. We will learn further how do we create the topic. Somebody arranged the topic. Any node can create. We can have the publisher to this topic, and any node can have the subscriber to this topic. And if the message appears in the topic, that means that everybody who is subscribed to this topic receives its own copy of the message. The topic could be arranged with two properties. One of them is its name, and second is the type of messages. So if somebody published in the topic the string, if somebody else would publish in that particular topic, I don't know, the number, then the ROS master node will crash. Yes, ROS master, the one that is called ROS core, is not particularly the node. It launches several master nodes. We will see further which exactly. But still, the master node exists. Okay, that is about topic. Okay, before I will show you some commands in the terminal. Let's reconnect just to not to divide our thoughts. Okay, let's reconnect right now. Okay, let's carry on. Yeah, the commands. So first of all, if Ctrl+C is the widespread command for stopping anything in ROS. So ROS core. If for some reason I launched ROS core by mistake, I press Ctrl+C. There are a lot of errors, but still that works to stop it. And there is no there is no easier way usually. Okay, not if. I'll start with it again. The most commands of ROS that start with ROS and something don't work without ROS master. So if, for example, I will write this particular command, ROS topic list, it will say us that there is no master. It isn't able to communicate with. So first of all, always when you work with ROS, you sacrifice one of your terminals for ROS core. So ROS core, this terminal is blocked. You can do anything here, but it won't have any effect. So this terminal is blocked forever. Forever when you work with ROS. Okay, this terminal will forever be hidden. Let's launch one more terminal. Okay, let's see which topics do we have by default. We can think that we have no topics, but we have some. These topics are logging topics where ROS provides all the information that happens in the system. Most likely you won't ever need them, these topics, but we can know some information about them with the command ROS topic info. ROS topic info and the name of the topic. No, let's say, for example, this one. No, come on. Okay, ROS out. It says which type of messages is stored in this topic, who publishes in this topic, and who is subscribed to this topic. So basically, nobody publishes here for some reason. I don't know why. Well, I know you don't know why. And there is one subscriber. This is the node that is called ROS out. Yes, the topic and the node are called in the same way. They always start with slash, but basically it's not important for ROS. So if you want to be, well, let me say a little more words about it. If you want to be very accurate, then you always have to keep this slash. The slash means that this topic is stored in the global namespace. Also, you can have access to this topic without any slashes. So if I say ROS topic info ROS out without any slash, it will say just the same thing. So in general, it doesn't really matter if there is slash or not. It's up to you. There are several specific situations where it is important, but now let's think that it is just some, I don't know how to say it, crazy mistake of developers. Okay, one more thing. You may not learn all these commands because there is very useful thing in Ubuntu in general and in ROS also. That is called tabulation. If I, for example, forgot how to type ROS topic, I type ROS T and forgot what to do next, I press tab twice, and it shows me everything that starts with ROS T. ROS test, don't know what is it, well, and ROS topic. Let's see what starts with ROS in general. There are a lot of commands. Exactly, this one is very interesting. Well, ROS core, ROS topic. These are known. And moreover, if you forgot what ROS topic can do, you press space and press tab twice, and it will show you which commands exist in ROS topic. Most likely, you will understand by its name what is happening in this command, but sometimes you still need to read documentation. -- help works. So ROS bv -- help. So it says that it shows the message. No, very nice help. Yeah. Well, you see how does it documental. Well, yeah. Okay, I don't know what does ROS topic bv does, so I have to Google it. It isn't important right now. Well, at least it says that we use ROS topic bv and the name of the topic. Okay. So important thing, we can use info like we used previously to see some information about this topic. We can use echo like to see what is published in this topic. We can use type to see this particular string. So if we say ROS topic type of ROS out. By the way, here I also could use tabulation button to avoid typos and press enter it will show us exactly the type of message. Okay, this is how to see the information about topics in the system. Very often you will face the situation when you see that something is happening incorrectly, but you don't know what exactly. The first thing that you have to begin with is to check which topics exist in the system. And if you can like predict them, then it will be easy to understand for you if everything is fine or not. Okay, let's go further. Topics can is the connection for nodes, but there is the like something between node and topic. I mean by between that I mean that inside of node there is the special publisher or subscriber for every particular topic. When we saw over here the publishers and subscribers, here were the name of nodes that contained these particular subscribers. So here, this subscribers ROSout means that the node called ROSout has the subscriber for this topic. It also can have subscribers to some other topics. Yes, the idea is that one node can have several subscribers and several publishers to several topics, maybe different topics. You can even publish to the topic. Maybe I mean this error can be like loop. You can publish to the topic where you subscribe, which you are subscribed to. That is possible. But in general, the general idea is that the node has several publishers and subscribers. Publisher is not like independent thing. Publisher is always the part of the node. So in general, I will say the node as a synonym, the word node as a synonym to the word subscriber sometimes. Or sometimes I will say the word subscriber as a synonym of word node. If and by this I will assume that the node does nothing but subscribing. Okay. Is it clear by now, or there are some questions? Because the further thing we will speak about nodes. Is it clear about topics to this moment? All that we should know about topics for now is that they provide some channels for delivering messages, and that on the ends of the topics, from one thing there is publisher, on one thing there is the subscriber, and to have access to the topic there is the ROS topic command. Okay, let's go further. Yeah, as well as ROS topic list, there is the command ROS node list that works exactly in the same way. ROS node list. Oh, yeah, by the way, ROS node, there are several also commands for ROS node. Okay, ROS node list. It shows existing nodes, and except of ROSout, this node, there is nothing more in the system. Okay, let's do something like unusual. Let's run some node. There is the tutorial node. I don't know if it's correct in English. ROS run. The node that is called total simulation. By total, this is like turtle, like turtle. To run any node, you have to specify two names. First name is the name of the package, and the second name is the name of the executable file. Every source code is structured in packages. So the package is called total sim for this example, and by pressing two tabs you can see all the nodes in this package. We will use this node. It's called total sim node. So total sim node. I used tabulation to avoid typos, and press enter. So here appears one window with total. Okay, and I will run one more node in another terminal because this terminal is blocked. Also, when you run some node, one terminal is blocked. Except you, of course, put here the ampersand symbol, this one. That means that you run something, how to say it, in the hidden mode. Let me not say you about Ubuntu. This is Ubuntu thing. Let's just think that we always run something and it always blocks the terminal. So there is a node. Let's run another one. ROS run total sim. Another one is called total teleop key. And when this window is active, I can press the up, down, left, and right buttons, and the total is moving. This is like the most exciting part of this lecture, when you can see that something is working with ROS. I think that first thing that you would do after you install ROS is play with total. So remember, this is called total sim, and two nodes that you need is total teleop key for manipulating and total sim node for the window. Okay. Yeah, this is how to run. This is slow slide how to run total sim. Yeah, before any task, let's just find out what is happening in the system right now. So okay, well, I launched some window. I somehow manipulated the total, but how does it work? Yep, let's find out. This terminal is also blocked, so I need another terminal for understanding what's happening. So we know two commands, ROS topic list and ROS node list. Let's call them ROS topic list. Okay, ROS out and ROS out AGG are known topics. They exist by default. Here there appears two or three more topics. CMD VL, I want to pay attention to this topic. In robotics, there is not the straight rule, the strong rule, but most often the topic with this name is used for sending commands for moving. It can be written as command velocity. So here in this topic, usually there are provided the commands for moving. Let's find out about this topic. So I predict that exactly by this topic we connect the node teleop key, the publisher of node teleop key, and the subscriber of node total sim. Let's find out. ROS topic info total one. No, please. Okay, it was slash. Yeah, for autocomplete for tabulation it means slash. Total one cmd vel. Enter. And yes, publisher to this topic is teleop total. Pay attention that this name is not exactly the same name. Yep, they're a little bit different. I'll tell a bit later why does it happen. But still, we can understand that teleop total is teleop key, and total sim and is the name of node. This one. This is also the subscriber. They connected with this thing. It is very, like, how to say it, very difficult to look at the connection between nodes and topics using the terminal. It's not very, how to say it? Well, it's difficult. So there is the ROS tool for visualization of graph of nodes and topics. It is called Rqt Graph. It is launched as any node of ROS. ROS run Rqt Graph. This is the name of the package. Oh, and the name of the node is the same. Rqt Graph. I press enter, and there appears Come on, there appears, please. Yeah, there appears the window that shows all existing nodes and topics. Circled, there are nodes. Squared, there are topics. So develop total and total sim, these two nodes, are connected with CMDVL. This is the name of node Rqt Graph, Rqt GUI Pi node. This is the ROS out node. And here you can see everything, who publishes where and who is subscribed where. Most likely when you run your own Rqt Graph for your own system, you will see another view. I don't remember which one exactly. Okay, so in this window there are several parameters that you can shuffle. I like the most informative view where everything is shown. So you saw when I put all the ticks, we saw only this node, and one arrow with the name of topic. I think that is not very informative. So here we see everything useful in the system. 1, 2, 3 nodes. 1, 2, 3, 4, 5, 6 topics. But the useful topic, maybe there are 2 useful topics. Okay, I said that I said that you can have several subscribers and several publishers to the topic. Let's create our own subscriber through the terminal. By Ctrl+C, I stop Rqt Graph. Let's check that our vision that this node provides the messages to this node by the topic that is called how was it called? I don't remember. By that topic, that this slot is true. Let's invoke ROS topic echo. This command, if I specify here the topic, CMDVL, this topic, it will place the circle one are topics. No, the second one are nodes. Let me show you again. These are the nodes, 1, 2, 3, 4, and the squared one are the topics. Okay, let's connect to this topic and try to output the result. No, not result, but to try to output every message that appears in this topic. That can be done with invoking ROS topic echo. Total 1 CMDVL. So now nothing happens. There are no messages in the system. Total doesn't move. Let's try to send one message. I'll press now the up button. Yep, you see the total moved, and in topic there appears one message that consists of 2 parts, linear and angular. Most likely it is speed. Yep. So if I press the right button, by right button I mean arrow keys, the right button, the total moved, and there appeared the message with 0 linear and not 0 angular speed. Now I will press randomly the buttons, and you see that the messages appears in the lower window. And most likely I will now press all 4 buttons, not simultaneously, but one by one. First one, second one, third one, fourth one. The only difference is in the first and the last number. This is the part of implementation of this particular node. It doesn't happen always. So this message, like this one, by the way, we can find out which exactly by invoking ROS topic info total1 cmd there is the geometry twist MSGs. We can say ROS MSG show and this name. Exactly this one. Yep. Linear of type, some type, angular of some type, and there are some variables xyz, xyz, float 64. This is another command that might be useful for you. I will pay attention further, more where it will be well further. Now for now, so here the most important thing that I wanted to show you here that really when I press the buttons here, I send some messages that we saw over here. Also, we can provide the message through the terminal. Here we created the almost subscriber, the one who subscribes to this topic and outputs the messages in this topic. We also can do vice versa. We can put some messages in the topic through the terminal. This thing was done with ROS-topic echo. With command ROS-topic pub from publish, we can publish some messages. For example, I don't remember the structure of this command. I can use tabulations for advice. I press tabulation twice. It puts the slash. So it expects here the topic. Okay, which topic exists in system? I press tab twice again. It shows me all the topics in system. I say, aha, that one is topic. Okay, char tab cm tab. Okay, what is next? I for instance don't remember what's happening, what is the structure of this command. I press tab again. It puts here the type of message. Do you remember that when I asked ROS message show, ROS topic info, it showed me the type of message. Here it is. Okay, so I could write it down by my hands. I could find out this name and put it here manually. But also I can put it with tabulation. I press tab again here, and it provides me the template of message that I should put in this topic. Okay, let's say that I want to rotate my turtle. So I put here some huge number. So I expect that the turtle would rotate on one place when I publish this message. Let's see if I'm right. Yes, I'm right. I'm not sure about your internet connection. Well, it moved fast. You will see it in the on video. Let's do it again. I'll rotate it for 1 radian. It rotated. Control C to stop. Once again, it rotates again. So I can also put the command to move to a turtle. And it, why didn't it move? Dude. Okay, something is wrong here. Maybe it's too large. Unexpected behavior. Is it still working? No, it doesn't work. Well, something is broken in the system. I have to relaunch. Maybe only this. Maybe to relaunch only this node would be enough. Oh yeah, it started to work when I tried to stop it. Okay, I launch this node again. I don't. Oh yeah. Okay, dude, stop it, please. Okay, I'll just stop the raw score and start it again. This happens sometimes. Okay, raw score is started. Total sim is spawned. Well, once again, I publish the message to move forward. Yeah, and it moved. 1000 is too much because this is like, I don't remember, maybe it is 10, the length of the square. So 1000 is too much, and it moved up to the wall. Okay, so sum up. 2 nodes by 1. I can again. Did it die again? Yeah. No, come on. Why does it happen? I don't understand why does it happen. Maybe I should stop this one. Maybe because it cannot move. It tries to move. So once again, this node and this is node. Why I can okay. Let's restart this node also. Yeah. When I restart the raw score, I also should restart existing node. I can move the total by sending messages from this node to this one. I can also connect the topics from the terminal. I can subscribe to the topics and publish to the topics, something from the terminal. To do this, I use the commands like ROS topic pub or ROS topic echo. Wait, where it was? Okay, it's somewhere here. ROS topic echo. If I forgot how to use one command or another, I can say ROS topic, and tabulations will show me how to do. So how to use it. So echo, list, pub, info, type. So now it is clear what do they do. This is your home task. No, it's not like the big home task. I will check it, but please try to do it when you will install ROS. Try to find out the type of messages. I have already done it. Please try to do it by yourself. I won't say it right now. What is the answer? There are the comments that could be useful for you. Try to find out the type of messages that are transferred between nodes, between total sim node and total teleop key. Okay, about Rqt Graph I already said that it's useful. Yeah, this is the publisher from the console. Yeah, this is how to publish the message. Yeah, the thing that I also want to show you about. Yes, this is the terminal for this window. Let's say this one. I can show. You see that if I say ROS topic pub total cmdvel. No, come on. cmdvel geometry twist. If I say one message, if it rotates, it does it just once. It rotates, but the terminal now is blocked. Yep, it is blocked with some meta publisher that is launched by ROS topic, and it says that we should press Ctrl+C to terminate. To avoid this behavior, if we just want to send only one message and to stop, I have to say ROS topic pub -1, like the key of arguments. What? It doesn't show. What? Okay, something was wrong. Let's say ROS topic. Once again, ROS topic pub -1 turtle 1 cmd geometry twist message to rotate like this. It says that the publishing message for 3 seconds, and then it stops to perform. Also, you can use the key that would send the message like forever. -R for rate and the number, for example, once per second. And then it will send one message by another every second. Well, the time of invoking if every message is approximately 1 second, so now we think that it moves always. But in general, we can say that it sends the message every second to move. By the way, we can check it. We can open another terminal and say ROS topic echo turtle1 cmd. And to see that really every second there appears the message. So this is one of debugging tool, the terminal. Yeah. So in general, when you create your own system, this is the way to find out if everything is working fine. ROS topic pub and ROS topic echo. Yeah, to stop it, also use Ctrl-C here and here. Ctrl-C is nice. Okay, the next part is talking about the development of source code. I think let's put it to the next lecture. For now, let's just stop on the part where we learned what are nodes, what are topics, and how to use them with the terminal. On the next lecture, we will find out how to create our workspace, which folders we have to use in this workspace to create our own packages with the source code. We'll also learn how to create the Python code of our publishers and subscribers, and try to create the program that makes the turtle move in the square. This will be on the next lecture. Okay, for now, are there any questions? Is it clear or I have to repeat something? By silence, there are two ways. Everything is clear, or everything is completely difficult and everybody like is shy to ask. Most likely it is difficult, but you cannot create the question. It is fine that it's difficult. I mean that this framework is this in this we use Python also. What do you mean? Here in the terminal, no. In the terminal, we just use some pre-built commands. Okay, once again, it is clear that this ROS is complicated thing. So please do two things during this week. Install ROS, try to launch this, according to this lecture, try to launch TurtleSim, try to play with this, and to find how to use ROS topic command, ROS topic pub, ROS topic info, ROS topic echo. Without this thing, the next lecture will be difficult. So please try to do some preparation. Okay? All right. All right. If there are no more questions, then I will upload this video to YouTube and provide you the link, both to YouTube and to the Moodle, where I would put this slide. All right. Thank you all for today's lecture. See you in the next week. Goodbye.